What do we have for question 7? What is the electron configuration for bromine? So now let's refer back to the periodic table. Okay. Now I know that we typically use, at least when I've been using the shorthand. But for this, we're actually going to we're actually going to use a longhand for this to kind of indicate why we use the shorthand. Okay. So for helium, let's start there because we want to go, the way we do electron configuration is literally start from hydrogen and you count through, assigning the appropriate subshell to it. So for helium, we start all the way at 1 because it's in the first row, S2. That would be helium, okay? And now neon, okay, is that we would start at helium, so that's at 1s2. We can actually just replace it, and then you have 2 because now it's starting at the second row, 2s2, 2p6. Okay, and then for argon, okay, and the reason why, actually I'll show you actually with an easier example, helium and neon. So helium, we have 1s2 because the first shell, the s1 is being filled, at least for the first row. So hydrogen, that would be 1s1, helium would be 1s2. We move on to neon, okay, then we go now down to 2s1, 2s2, 2p1 starting the boron, 2p2, 2p3, 2p4, 2p5, 2p6. Okay, and then you probably guessed it, for argon we start now at 3s1, 3s2, and then 3p1, 3p2, 3p3, 3p4, 3p5, 3p6 on the argon. Okay, so exactly would reflect that starting at the neon. Okay, it would be 3s2, 3p6. Now let's go all the way to krypton. I know that it was asking for bromine, but krypton, okay, it's a little bit different. Exactly, start at argon, and then you do the same thing. It'll be 4s2, but you have to actually pass through this row as well. So now the way this row works, okay, is slightly different from I guess the other ones, right? So we're actually now with the D shell, that's the ones here starting at Scandium, it'd be 3D1. So you've actually gone back a shell and you start counting there. So 3D1, 3D2, 3D3, 3D4 on the chromium, 3D5 on the manganese, 3D6 on the iron, 3D7 on the cobalt, 3D8 on the nickel, 3D9 on the copper, and 3D10 on the zinc. So 3D10, and then you go back to counting as regular, where it would be 3p1, 3p2, 3p3, 3p4, 3p5 on the bromine, and 3p6 on the starting at the gallium, it would go back to the 4. So not 3 anymore, it would be 4 again. So it would be 4p1, 4p2, 4p3, 4p4 in selenium, 4p5 in bromine, and 4p6 on the krypton. But you actually would want to reorganize this to where you have the lowest shell number in front, which is indicated by the coefficient in front. So 3d10, 4s2, 4p6. Okay, so that would be actually how you broke that down. Okay, so in total, if you wanted to write down the whole thing from helium to krypton, it'd be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Okay, but for this question, they're asking for bromine, not krypton. So we did technically pass bromine, right? So remember that it was 4p5. So literally be exactly the same as we've written above here, but it would be not 4p6, it'd be 4p5. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 4s2 4p5. Okay, and if you want to write down the shorthanded version, okay, it would be starting Argon as in the most recent, kind of like with the krypton, the most recent noble gas, and we just have to fill out the valence shell, and including also the D level as well. So the 3d10 4s2 4p5 would be the shorthanded version for bromine. Okay, now the reason why I broke it down like this is because I'm hoping you're seeing how I'm even getting the subshells and how I count them through using the periodic table. Okay, so this hydrogen and beryllium, well, columns 1 and 2 kind of as pretty much like the S shell, including helium, which is all the way over here, and then the columns 13 through 18, not including helium, are the P shell. Columns 3 to 12 refer to the D shell, and then the one we don't really address here, but the lanthanum and actinium series, that counts as the F shell. Okay, so yeah, let's see how we did. So exactly, technically this is correct, but also incorrect, because you still want to make sure that you're starting always with the lowest I guess electron shell number, which is the coefficient. So it should actually be 3d10 4s2 4p5. But yeah, so exactly, it's explaining how the periodic table fills out, and exactly it's telling you how each orbital has a certain amount of electrons. So after filling it out, they do have the 4s2 3d10 4p5. So that I would just reorganize that to make sure the 3d10 is in front. Okay, and this is actually a very fantastic picture showing the electron configuration. As you saw when we were solving for bromine, we had a 4s2 3d10 because it covered this whole D row, and then we went back to the 4s and we ended at 4p5. Okay, so this is correct, although it should be reorganized with lowest shell first. So it's gonna be Argon 3d10 4s2 4p6. Okay, the reason why I keep emphasizing that is because some chemistry professors, teachers can be very specific